All right. So 26206. Let's see. Installing cable and conduit systems. To install cable and conduit system, we're going to plan the installation, identify pulling locations, and set up the cable reels, prepare raceways for conductors, install a pull line, prepare cable ends for pulling, select cable pulling equipment. So, fishing conductors and conduit. There are 3 types of fish tapes. Move this little picture here. So this right here, the illustration they're sending right here is a basket grip. And essentially the whole purpose of that basket grip is to clamp onto a single conductor. It's not necessarily designed.
Start over. For some reason, all like cut off and then reconnected like 5 seconds ago.
Yeah. Okay, no problem. It says there's different types of fish tape. So if we want to send in fish tape into a conduit, what's the purpose of fish tape? Obviously, so that you can send a stiff enough. It's not a conductor's per se. It's a stiff enough line to be able to grab a hold of a cable or wire and actually pull it through the conduit. And the illustration down below right here
is something with enough tensile strength to hold the wire and pull it through the conductor without it snapping in the middle.
Absolutely.
Again.
Absolutely. So now the basket grips, they're used to hold the conductor to fish tape and eliminate the need for taping wires. I have found that these don't work as good as most people would like for them to. And so taping is typically the way we do it. So, all right. So these are different type of cable dispenser. Have you ever used any of these on the job site?
No.
No. I've made my own.
We never had to run that long line.
Okay. They're definitely convenient to have. It keeps your wires flat, keeps them rolling smooth. I've actually used to manufacture my own. I mean, they obviously don't look this fancy, but just a few 2x4s, and we just hang them from the rafters, whatever, and we just pull it and it come off. So, of course, these at the bottom are the wheeled caddies for pulling wire through conduit. Planning and steps for pulling cable. Proper planning is critical for the safety and the success of a cable pull. Before pulling, measure the run and order the cable so the reel length matches the pull. Pull cable from the shipping reels whenever possible to minimize the damage and waste. So as you can see right here, it's giving you the steps for planning and pulling your cable. Now, obviously, this isn't necessarily pulling for Romex, okay? This is planning for pulling for larger cables, for feeders and stuff like that to go into some larger panels and equipment. Setting up for wire pulling, an equipment checklist will save time. Setting up for a cable pull, different items may be needed based on the type of equipment used and the installation. So that's what this illustration right here shows, is the equipment checklist. So I love checklists.
A lot of things.
Yeah, it is a lot of things. And you can scratch off some of them because they just don't apply. So let's see here. Oh, back up. Let me let Charles know. I can't talk right now. There we go. All right. Proper and improper ways of transporting cable reels. Pretty much a no-brainer on some of those. Look at the no's versus the yeses. You notice how all the yeses, there's no impact directly on the actual cable itself. So, all right. let's see. All right, moving on. Reel jacks are essentially just jacks set up for your cable reels to spool on. 2 stands and a spindle required for each reel. They have to be able to withstand the load of the cable reel. These are pretty heavy duty right here, but if you're makeshifting one, all right, so right here, faults may be detected when you're running a mandrel through your conduit. So a lot of times we'll run a mandrel through a conduit to remove any type of debris, trash, or anything else like that that gets put into the conduit. So as you can see right here down at the bottom, it says concrete sediment. That's going to impede that mandrel from getting actually to go through there. And the importance of that is so that you know that, hey, if my mandrel can't go through it, my wires can't go through it, or my cables can't go through it. So that's why it's good to do a test pull like that. As you can see where a backhoe tooth mark actually went into the conduit. So these are all things that could happen to your conduit after it's already been put in. You left, other contractors have come in. Next thing you know, you got damaged pipe. It gives you an idea using that mandrel because it's based off of the length of the pull rope and stuff like that. So you can identify about where these damages are located. So devices used to inspect, clean, and lubricate the raceways. Mandrel is used to check a go-no-go checks. Conduit swab is used to remove debris and to apply a film of pulling compound for easier pulling, and a brush can be used to remove sand and other light obstructions. Obtaining the greatest possible conductor sweep in a pull box. So when we're measuring conductor runs, be sure to allow sufficient room through pull boxes. Allow the largest possible conductor sweep to eliminate sharp bends and potential damage to the conductors. So power finishing systems. So if we need to actually pull a line in, we'll use a vacuum system with we use essentially a styrofoam, and we'll suck in a nylon string using the vacuum system. Have you ever done that before, Matthew?
I cannot say I have.
Okay, so that's super important that we do that at some point. Just because we use fish tapes a lot, but there's some pulls was like, man, for just being faster, it's easier to go ahead and just run suck it through the vacuum system, and then you attach a rope to the end of the string line and pull the rope through using that string line. So in this system right here, has a vacuum system. Most blowers, so this one's blowing, provide enough pressure to clean dirt, water from the conduit system during the finish operation. This shows a step. Types of pistons in common use. Blower vacuum systems are provided with piston kits to accommodate various conduit sizes. Guide vans are supplied on pistons for larger conduit. Various types of pulling grips. The conductor must be securely attached to the pull line for safety. Basket grips are typically used on short pulls, while longer pulls use a cable grip connection. All equipment used in a pull must have a working load rated in excess of maximum force applied during the pull. Like I said, not a big fan of pull grips at all. I've just never really found them to work that well. All right, this is a cable puller. So now we've pulled our string line in. Now we've got our rope run through it. Now we've attached to our cables. Now we actually have to pull it through the actual pipe. So this here is a cable puller that's actual electric. The number of wraps on the capstan, obviously that's the capstan, determines the force of the pull cable. To facilitate pulling, add lubricant through the conduit and on the cable that is compatible with the wire being pulled. I'm gonna go ahead and say this. It's better to put it on the cable versus trying to stuff it in the pipe, but always, always make sure that you are at least 5 foot away from the opening of that pipe while you're doing the lubing. You don't want your hand to accidentally get stuck in between two pieces of cable while that puller is pulling that cable through that pipe, because you have to have time to be able to tell them to stop pulling. And it takes a good, couple seconds to get to the, the off switch versus on, while you're on the radio and stuff. So definitely want to be careful of that on the lubing end of that. Due to the strain on the cable, discard the wrap position of the cable after making. Cable pullers. As you can see, there's so many different types here. You got your mechanical, you got your force gauged, that's electric motorized. And then of course, this here's a 2000 pulling capacity type as well. Now, these chutes right here, these are actually designed to set into panels so that you have a straight pull, so you're not pulling against the edge of your panel and breaking your panel or anything. So it's important that you align to make sure that these cable pulls right here are in symmetry with the direction that your conduit's running. Perfect example right there. To set up for a down pull, adjust the elbow and boom of the puller to the correct angle and lock the elbow to the upper conduit. So if I'm pulling here, I'm locked into the top conduit, so it's a straight pull up. That way I'm not putting a lot of stress on that panel right here. An up pull is set the same way, except you're attached to the down, the lower conduit. Cable length meters. Never seen one of these. But it looks like you literally attach it to both ends of the conductor. It sends in a pulse through the actual conductor and identifies how long the cable is.
It probably does it to voltage drop
Probably, yeah.
equations.
All right, so what is the purpose of each of these items? What do you think?
Fast grip is to pull wire through a conduit.
Okay, it's to grab the actual, right?
Fish tape more days.
You still use a fish tape with them, but the basket grip prevents you from having to use tape. And a circuit tester.
Oh, right.
All right, and circuit tester obviously is to trace conductors.
Yeah, you're waiting for me? Sorry.
Yes, yeah, no worries.
A circuit tester. I don't know. I remember seeing that. I don't remember seeing that part for some reason.
We didn't.
Circuit tester's just meant to measure if there's power on the circuit, right?
Absolutely, just to make sure there's no power on the circuit. Conduit swab.
Conduit swab is to get the lubricant on all sides of the conduit, so it's equally distributed.
Absolutely. All right. And a mandrel.
Oh, it's a bit harder.
Remember,
No, it's not
the go no go.
Oh, it's so if you have it's meant to test the pipe, so you don't just try to run a wire through the pipe and it won't
Absolutely.
get stuck on a myriad of things that have been thrown into the pipe ever since you last been there or it last been installed.
Absolutely, good job. All right. Hey, Joe. In here. All right, so let's see. Share the screen. There we go. All right, so the second part of this, high force cable pulling. We're going to set up high force cable pulling by setting up the feeding end, supporting conductors, and pull cable into cable trays. So we got high force cable pulling setups are require careful planning to ensure a safe and smooth operation. Communications equipment is required between both ends of the pull. So as the illustration shows here, the cable pulling apparatus, so it's being pulled this way. The cables are set up in line right here to be fed through the conduits and then that way. To unreel the cable along its natural curvature. We don't want it, this here would create issues. So make sure you do it so if the reel comes off, it's feeding into it properly. Cable feed and setups. See how it's real tight bend right there. It says auxiliary equipment can be used to facilitate the installation. Typical equipment includes reels, guides, and sheaves. Sheaves are obviously different rollers that are put in place to inhibit sharp angles. Cable sheaves in a setup, single sheaves are available in various sizes. Assemblies are also available for pulling around bends. They must be matched to bend to ensure a smooth pull. Never allow a polygon curvature to occur in a cable pulling operation. Sheaves and pulleys must be positioned carefully to ensure a smooth radius, no sharp turns. Sharp turns increase the resistance, may cause damage. Supporting conductors, NEC section 300.19 contains requirements for vertical raceway pulls. That means we're pulling straight up and down. One conductor support must be installed at the top of the vertical raceway, and intermediate supports must be provided at intervals no greater than the length shown here. One conductor support must be installed at the top of the vertical raceway, and intermediate support must be provided no greater than the length shown here. Okay. So if you're running a number 2, then it can't be no greater than 180 feet. No less. Yeah, your run can't be no more than 180 foot without support. 80 feet per conductor. Now, Matthew, what was the purpose of these wedges here? What do you think the purpose of those wedges?
To make sure the wire don't kink or cross over with each other a whole bunch.
You're not wrong, but in addition, their primary purpose is this is actually inside a cabinet or a stud wall where your conductors are coming in, and the purpose of those wedges is to support the weight of that cable. Because if you're making a vertical pull straight up, that wire has weight to it, so gravity is also working against. So can you imagine if you went up 20 feet and those were hooked to actual lugs in a panel? They'd probably eventually just rip the plug straight out of the panel, wouldn't they? Just based off of the weight. So yeah, that's the purpose of putting those wedges in there. So as you're pulling up, obviously there's no pressure, but when it goes to put the weight back down on it, that's when them wedges will actually just really clamp in on them. So conductors installed vertical raceways can be supported with wedges. The clamps are also required where wedges cannot be sufficient support. They may also be supported by installing covered boxes at the required intervals. All right, so if we're running down a cable tray, you have to put in these wedges here, or sheaves rather, to ensure you don't have a sharp and you don't cut your wire on anything. So cable tray installations require the use of sheaves and rollers to prevent the excess strain and insulation damage. Sheaves must be supported in the opposite direction of the pull to compensate for the force of the pull. Whenever possible, install cables in a steady, continuous pull. All right. Play. There we go. All right, cable limitations when pulling. Total pulling tension equals the length of the raceway run in feet or meters, the weight of the cable in pounds per foot, and the coefficient of the fraction. So length times weight times the coefficient of the fraction equals the total pulling tension. All right. Identifying cable limitations when pulling, we're going to calculate the allowable tension on pulling devices, calculate the allowable tension on conductors, and calculate the sidewall loading. All right, pulling subjects' cables to extreme stress can result in damage if precautions are not followed. Be aware of the cable's maximum pulling tension as well as sidewall loading and bending radii. The allowable tension on various types of conductors are shown here. Copper, aluminum, so forth. The angle of bend versus the coefficient of the fraction. To calculate tension in horizontal pulls, multiply your length of the raceway times the weight and times the coefficient. So for curved sections, multiply the tension into the bend by logarithmic value and the fraction at a specific angle. Yeah, this looks awesome, don't it? Seemed to me like it wasn't too long ago, James Bigby actually came to me and he asked me a question and I couldn't find that answer in here because I think they actually had the wrong answer in the workbook. So you run into that problem in one of the workbook questions and you just can't figure out why, there's a good chance it's wrong. All right, the sidewall load is the radial force exerted on a cable being pulled around a conduit bend or sheet. Excess sidewall loading can crush a cable and can be reduced by increasing the radius of the bend. Sidewall load. Did you know, we're talking about sidewall load, the reason we put in rigid, actual metal 90-degree sweeps under concrete for cable pulls is because of that sidewall load. Because when you're pulling those big cables through your conduit under a slab, it'll just actually, it could break the PVC 90s. That's why we use rigid.
The concrete weight can break the slab?
No, the actual pull of the cable. So if I'm pulling vertical, say
Yes.
I'm pulling through and I come up, that bend, that sidewall pressure, if it's not strong enough and you're pulling with the X amount of force and that cable isn't being pushed as well as pulled, then it could actually break that 90.
Ah, all right.
But when you break it, now you're exposing moisture in your conduit, and therefore you start having electrical issues. So that's why they actually make it, it's a requirement to actually use rigid 90s.
Okay.
The sidewall load, go ahead.
No, I was saying thank you for that.
Oh, yes. Yeah. So the sidewall load on any raceway run should not exceed the value shown here. These values may vary by manufacturer. Always refer to the specifications of the cable in use. 600 volt, non-shielded, so forth and so on. You can read. Sample conduit run. Assuming that a cable installed here weighs 8 pounds per foot, the tension between A and B can be calculated as follows. Length times width times coefficient. 300 times 8 times 0.5 equals 1,200 pounds. That is the tension. 1,200 pounds of tension. Wow, that's a lot. Okay, do you guys have any questions or concerns about the module we just covered?
Not really.
No, sir.
If I have any, Comes with the clarity. I have the book. I can just super read. If not, I'll come and ask a question or 12.
All right, well, we can do this real quick. Won't take just a moment. Let's see. Well, shoot. I'm looking to see. Here we go. That makes no sense. There we go. So let's go through the questions and answers here real quick. See how we measure up here. There we go. All right. So due to the risk of runways, what should be used on all long vertical cable pulls? Oh,
Braking system. And that was
braking system. Let me look right here real quick just to see.
Basket grips.
So basket grips, you remember, that's to keep from having to use tape. So that's definitely not it. Vertical pulls are going to be the those wedges.
Oh. Yeah, I got it.
That'd be used as a braking system, right? So a mandrel should be approximately what percentage of the conduit size? Obviously, it can't be the full size, right? It's going to be a tight pull all the way. So when we're dealing with a mandrel, how big it should be to be able to tell if you can pull your cables through that pipe unobstructed?
I got 80%.
80 is what I'm seeing also. Would you agree with that, Matthew?
And the reason.
Yeah.
Oops.
All right, so number 3. Straight and swivel are 2 types of what?
I got Clevis. I had to Google what Clevis was when I was doing this. I'd never heard it before.
Yep. So in the book, is it not written in the book?
It is, but it just talks about what the equipment was, and I didn't know what it was.
A clevis should be a type of
Like a
gosh,
swivel.
dog.
I think of a fishing swivel as of it, or like a line swivel.
Yeah, I could see that.
I never used it though, so I wouldn't know what it is.
Yeah, let me look in here to make sure it's what I think it is. So, Clevis. And that is in what section? That is in
26. Yeah, and it's page 13.
Thank you. Yep, there it is. You're absolutely right. Yep. All right. All right. The feed-in setup should unreel the cable. So if we're going to feed the cable and we're going to unreel the cable into the conduit, should we do it in a reverse S? Nope. Because that means we're coming in from underneath and going over like that, right? We never want to do that. In a circular manner, well, it'll be doing this.
It's D.
That is correct.
Along its natural curvature.
Yeah, along its natural curvature. There you go. All right. Which of the following determines the amount of force applied to a pull?
Number of wraps on a capstan.
An important first step when planning and preparing for a cable pull is to do what?
Measure twice, cut once.
Measure the length.
Absolutely. Make sure you get enough cable. The ends of 1,000 kc mil conductors can be trimmed using what?
Cable cutters. I'll have fun trying to do that with scissors.
I'm gonna say, I don't think I'm gonna be able to do it with scissors. The three types of fish tapes are steel, nylon, and what?
Fiberglass.
Yes, it is. The ideal device for lifting and transporting large cable reels is by using
Forklift.
verify that. Yep, it is a forklift. So when pulling cable with
Oh no, number 10.
yep. So when pulling cable with a capstan, what is the maximum pulling speed that should be utilized?
No. I gotta look it up.
Yep.
I'm guessing it's 40 from the way you're hovering around it.
We're gonna lean toward 40 feet per minute. Yeah, we'll find that in 3.0. All right, so number 11, the most important tool for supervising a high force cable pull is doing what?
Ooh.
You can find that in 2.0.0.
Working communication. Working communication equipment.
That is correct. Which of the following is the most common types of wire pulling rope on the market? Ooh.
Nylon.
1.4.0.
Nylon.
Nylon it is.
Polyurethane, multiplex polyester, double braided polyester composite, and that's the only one that shows up.
Yep. What is the total pulling tension when pulling a cable weighing 5 pounds through a 5 pounds per foot through a 500-foot conduit with a coefficient fraction of 0.35? So that's 5 times 500 times 0.35.
Gonna be C probably. It's 2,500 times 0.35. If anything, closest number there is 875.
Said right here.
Yes.
13, that is correct. All right. In general, the pulling exerted on a cable pulled through cable trays using a basket grip not attached to the conductor should not exceed. We can find that in
6.5.
2.3.
£1,000.
1,000 pounds it is. All right. I have to read a little bit here. One end of the pulling rope is attached to a cable grip. The other end is doing what? We can find that. What number is that? 15? 1.6. Lightning cable pulling equipment. One end of the previously installed pulling rope is attached to the clevis, basket, or cable grip, to which the conductors are attached. The other end of the rope or cable puller is wrapped around the rotating drum, also known as a capstan, on the cable puller. Before starting a cable pull, make sure that both ends of the cable are permanently identified. All communication equipment is working. The cable unreeled or the cable is correctly spliced. Always think about safety. So what do you think the answer is?
Communication equipment.
Communication equipment. Because what makes good, if I remember what I was telling you about lubricating your cable, wouldn't be any good if I'm yelling on the radio, stop, 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 and they can't hear you because it didn't check the communication. In general, the sidewall load on any raceway run should not exceed what? It's going to be 3.3.
$500.
500. The preferred method for checking for damaged conduit before pulling cable is to do what? What's the purpose of the
C or B.
we're going to run a test pull just to see if we run into any issues first. Now, when we run that mandrel and it comes out and it's soaking wet, that's when we're going to use the vacuum system then. If it comes through and we see there's a lot of like dust and stuff on it, then that's when we're going to run the conduit swab and so forth, which we'll probably run that anyways after we run this. So what is the maximum length of cable weighing 5 pounds that can be pulled through 45-degree bend with a coefficient of 1.4 using equipment with a maximum pulling force of 2,000 pounds? So it looks like we're going to multiply, maybe divide. Haven't seen that one. So number 19 is in 3.2, section 3.2. Tension into a bend, coefficient. Let's see here. 1.48. That is not the right answer. On conductors, phase, conductor strength numbers, any wire conductor will break if stretched beyond, reduce the max tension by 20 to 40%, so will be pulled simultaneously. Huh. All right. We're gonna. All right, so you guys are aware that we're in a stay-home status for the state of Florida now. Starting, I think it's what, in 2 days? You guys aware of that?
I am.
Oh,
Like, it really makes a difference for me. I have not left my house in like 3 days.
What does that mean? Does that mean that we can't even go to walk?
I don't know. We'll talk about that after this. So we'll wrap this up. So the answer is 270 is your length. We'll look into that some more later, but that's going to be in section 3.2.0. If y'all good, put your mics on mute, please. Thank you. We're just going to wrap this last bit up of this session, then we'll move forward. Typical hand crank wire puller using 30 pounds of force can pull up to 1,500 pounds. We can find that in section 1.6.2. All right. I think that's that. All right, so if you guys have any questions, let me know. I'll try and answer any questions on this particular one on 26.206. So I'm gonna go ahead and end the recording now. And I'm thinking I'll be able to publish this shortly. So let me see.